So the analogous to, just like with concat, we had append. With merge, we have join. So what join does is takes an existing data frame and merges in a second one to it. So here we have left and right, and by default, here's an important difference. In fact, I will show you this cool thing. If you use stars, you can make markdown bold, so I can bold that part. But joins on indexes by default, rather than trying to join on common columns, which is the default behavior for merge. So yeah, if you know you're going to join on indexes, you can prefer to use join instead of merge, but you can get the same thing with either one. So here we've created these data frames with indexes that match. So we have K0 is found in both, and K2 is found in both, but K1 is only found in left, and K3 is only found in right. So if we take left and we join right to it, and we have 4 different ways, we can either say how equals left, so we're going to keep everything in left and then add just the parts in right that match, or we can do the opposite and just keep the parts in keep all of right and then only the parts in left that match. We can do inner or outer. So again, remember, only the indexes K0 and K2 are found in both. So if we do inner, we only get those rows. If we do outer, we get all 4, and then we just have some nan values where we have column names and index names that have no values in one data frame or the other. So if here we're gonna create 2 more data frames called left and right, and in this case they have different values. They have the same indexes, but they have also the same column names. So when we merge these, unlike with concatenate, where concatenate would allow us to have redundant column names, with merge we don't want that, because we're merging these things. So if we have so if we're merging, so we have here columns K and V, and we're going to merge on K. So there will only be one column K in the output because we're merging that. So we're gonna have one column K, and we're just gonna match up the values that match. But we have 2 column V's, one from the left and one from the right. So what merge is going to do is it's going to keep both, and it's going to rename them for us, because typically we want to avoid this, but if it happens, it's fine. So what it's going to do is it's going to append _x to the left one, and it's going to append _y to the right one. So we get basically it's keeping that information, but it's saying, just so you know, you had the same column name in these 2 things, and are you sure? We're not going to throw out those columns, but you want to be aware that they're duplicated. So one option that we have here is we can provide what we call suffixes. So if there are merged columns, we can say I don't want to use X and Y, I want to use L and R. So this would be the same thing, but underscore L and R, we could say left and right, or 1 and 2, whatever we prefer based on our context. So here's an example. So why would we want to, this is more general, why would we want to use merging at all? So I'll give you an example of, say we're doing some gene expression. Gene expression tables. So we have one data frame where we have the counts. So we have these three genes and the counts, number of times we've observed them. And we have another. So this is say our data from our gene expression experiment. And all we have are the names. Well, if we're looking at this table, it's really hard to see what's going on. Like, is this like, all right, this gene is highly expressed. Well, what is it? CDS3 doesn't really tell me a lot. It'd be really nice to know what it is. And if I look in the table down here, I can see that it's an aldolase. Okay, great. That's more useful. But those are in two separate tables. You can imagine these are massive tables. And every time you're going through your gene table, you're thinking, okay, this is great, but I don't know what these mean. I don't have the description of the gene, or I don't have the annotation of the data to know what it is. So you'd really like to be able to merge these two tables and have not just the data and the name of the gene, but also like some information about it. So we can use a merge to do that. So we can merge these two data frames here, and we're going to create a third one called DEGs, differentially expressed genes, plus names. So now, in addition to having just the name of the gene, we have the description. So it's a lot more useful. And by default, I didn't mention this part exactly, but this on equals will, if you don't specify, it will be inferred from the overlapping column names of the two data frames. So since both of these column names had something called gene, it realized that that's probably what I wanted to merge on. Typically, I don't leave it up to chance, but by default, it will do that. And also, by default, it uses inner. Another example, now showing merging on indexes. So here we have what I'm going to do, and this is a nice trick, is I'm going to take this table differentially expressed genes, and I'm going to make, let's say I've already imported this data, and I want to change the index. It'd be really nice to have the index as the gene name. And same thing with the description. So I can do something where I say, I'm going to take this data frame, the gene column, and I'm going to store that as that data frame, the index column. And then I'm going to view the value. So when I do that, you can see that now I have the same data, but now I've renamed the index to be what's in this column. And I can do the same thing with the description table. So now I've renamed the index to this. So I can now merge them by index if I want. I can say left is this, left is DEGs, right is names, and then left index equals true, right index equals true. And so because I have a duplicate column in each one of the name of the gene, it's going to give me this underscore X and Y saying that these came from two different tables. But the key thing is that I can merge on index now. So one other example is or I'll go through an example where we can see some of these things in action. So first thing we're going to do is set the maximum number of data frame rows displayed. So I showed you this a couple lessons ago, but you can use this pd.setOption display max rows, and this will change the number of rows that we get. This is just so in this example our screen doesn't get filled up with output when we look at things. So let's see if this works. We're going to read this text file of World Series winners, and we're going to rename the columns. Let's see. Okay, so if you get an error like this, what we're going to do is, let's see. I think did we decide that it was in the working directory? No, that was the scripts peer data. Okay. So we have two options. We can either, so I'm going to open up another terminal, and remember our working directory is lessons. This is where we are now. And we can see if we have something called data that's in the same level, so we go up one and then down into data. We should have created that. Do you guys, does this command work for you? Do you have something called data that's in the same? Okay. So let's change into that. So we're now in our SIO209 folder and then the data folder within that, or directory. So now we're going to go to GitHub, go back to the main page, and then click on data, and then World Series winners, and then raw, and copy that, curl -capital O. So we've now downloaded that text file. You can just look at it. And even though it only has one column, we can still import that as a data frame. It's a CSV. It's just a single column CSV file, so there's actually no commas. And we can rename that column team. And so we now have a data frame with a single column and an index that's just a numerical index. And because we set display max rows 10, we're only seeing 10 rows here. So 5 at the beginning and 5 at the end. Now so when I taught this lesson last year, it was just after the Chicago Cubs had won the World Series, and I added that to the data frame. So we concatenated this new entry. So we already know who won last year's World Series. I'm predicting that the San Diego Padres will win the World Series this year. Come back to me in 7 or 8 months. We'll see if that's true. So we're going to concatenate these two data frames. So we have the data frame of World Series winners, and we have the data frame of the new winner. So we have this list of these two data frames, and we're going to concatenate them, and we're going to say ignore index equals true. This will, instead of putting a little 0 at the end for the Padres, it will just give us the next winner. So here we have now, I'm predicting the future. Padres will be the next World Series winner. Now, I can add a column as well. So this is not using a concatenate function, but rather just specifying a new column. So this is our df2 here, and what I can do is I can say df2 in brackets year. So this is not a column that exists. So when I refer to this column, it if I was going to if I wanted to display this column, it would give me an error. But since I'm storing something into it, it will work. So I can say numpy. This is np is numpy.arange, and I know that the first year in this column is 1903 because I downloaded the data, and I know that Boston Americans won the World Series in 1903, and I also know that every entry in this data frame is a year. So even like this year where there was no World Series, it just says no World Series. So I know I can safely add this column of year and it will be accurate. And I'm going to go through, so the Padres are going to win in 2018, so I want the A range to go to 2019, right? Because it's not going to give me that. So it has to be the right length, otherwise it'll give me an error. And secondly, I'm going to add the first initial of the team. So that's going to be another column. So, and then we're going to do, for this, we're going to do a list comprehension. So we're going to say for team in df2 team, give me team letter 0, so the first letter. This is super useful in pandas to do a list comprehension. So basically, you can create a new column on an existing column using a list comprehension, and it will go through and it will take this. This is effectively a pandas series. It's a column of a pandas data frame. It will iterate through it and generate something as a list, but then when you save that list as a new column, you've now created another series or another column in your data frame. And so it's very handy to be able to do this, to take some information in one column and use that to create a second column. So that's what we're going to do here. So now we've now added a column for year, and we've added a column for the first initial. Now we have a couple new functions. So stack and unstack. So what stack will do is generate a multi-index let's just see what it is. A multi-index series where we have the index and the team and the year. It will sort of create a so if we say oh yeah. So it sort of creates a multi-index object that we can use, and I will add some examples to see how you can use this. But I guess the basic one here would be, so for this series, we can get index number 113. So if we had just 113 here, this would be. It's just a different way to access the data. So it's turning this data frame into a series, and the ultimate it carries the same information, but it's indexed in such a way that we can just access the information in a different way. So here we have element number 113, and then the team. We can pull out then the team from that, so we can see we can do we can merge these indexes together, or stack these indexes together.
Is there a way to turn the stack object into a data frame? I don't know what I'm asking.
We can try. Yeah. Yeah, that's a good question. It's easier to see maybe here how that's done. So basically, we only have one. We've kind of like stacked everything up on top of itself. So we only have, it's now a series. So but the types of that series are different. So to access information, we have to do a hierarchical index.
Not exactly possible.
Yeah. Mm-hmm. Yeah, this is one of these that I don't use a lot, but there's some times when it's like the only way to get what you want. And so unstack is similar, but kind of handles it differently. So you can see that all the teams are together, and then so you can refer to the team first and then to the index. And we can try to make a all right, and then we're not seeing here, but the year would be in the middle here. So we have I guess the main difference is whether the names are a little confusing. Stack and unstack. Stack makes sense. Unstack's kind of just like it does the same thing but in a different way. So instead of putting the index as the highest hierarchical index, it goes in the lower level, and then the column names are the highest level. Yeah. So let's, one other thing we can do is, okay, yeah. So stack is not a pandas option. It's the way that we would do this would be df.stack. Yeah, df2 is what it was called. So the way that the docstring describes it is that we pivot a level of the possibly hierarchical, but don't have to be column labels, returning a data frame, or in this case a series, in the case of an object with a single level of column labels. So it returns a series having a hierarchical index with a new innermost level of row labels. The level involved will automatically get sorted. So here's a simpler example. We're taking this data frame and it's generating a series that has a hierarchical index. We haven't really covered hierarchical indexes yet, but yeah. So one other thing is, let's see. Okay, in this case, I'm going to just change the path because we should already have this file in our lessons folder. No. Oh, it's the transcribed version. Okay, so I'm going to change that back, and we're going to have to download this file. So same as usual, we copy the raw format of the file. This is survey scores 2015, and now it should work. So this is just a data frame where we have all the student names, which are just de-identified as numbers, and then some information about their experience using computers. So you guys did a similar survey this year. So we're going to first transpose that and save it as DF. So now our data frame is kind of in a more logical table format here. And we can see that the types are all object because it was originally in this format, and so it maintains them as objects. And we're just going to do some basic stuff. We can index this to get all rows and just columns from the here to the end. So basically what we want to do is to stack and unstack. We just want to get the numeric columns. So we're going to define this list of the numeric columns, and then we're going to take the data frame, just those columns, make it numeric. We saw this last time, and replace those same columns in place. So now we've converted the numeric columns to numeric. And so here's a case where you now have the ability to do to use these hierarchical indexes to get information about the student. So you can say, okay, I want student 10,000 and this information about their experience. Or you could do the unstack and kind of reverse the way the indexes are stored. Okay, I will just pause the video here for a second.